Hello and welcome back, everyone. Today we will be discussing metadata and artificial intelligence, its history, various uses, and some examples to help illustrate its importance in the field of AI, or artificial intelligence, but you should know that by now. And I know I forgot, but if you are just jumping straight into this particular video, I'll do this now, and I'll try not to forget in future videos. But my name is Heriberto Ramirez. Feel free to call me Eddie or Profesor Ramirez. Again, before we dive into the details, let's first define what we mean by metadata in the context of artificial intelligence. Sorry about that. And if you are just joining us, I do tend to say metadata and metadata. I try to stick on metadata, and I suggest you pick one, but forgive me, as I will probably more than likely say both. So let me try that sentence again. We're going to cover what we mean by metadata in the context of artificial intelligence. Metadata is a general concept that refers to data that provides information about other data. In AI, or artificial intelligence, metadata typically refers to the information that describes, annotates, or characterizes various aspects of AI systems, such as the data used for training, the models themselves, or the deployment of AI solutions. Metadata is essential in AI for several reasons. First, it provides context and clarity for the AI development process, helping engineers and researchers understand the components and characteristics of the AI system. This understanding is critical for making informed decisions during the development, evaluation, and deployment of AI solutions. Second, metadata serves as a vital tool to ensuring the reproducibility, reliability, and transparency of AI systems. It helps identify potential issues such as biases, inconsistencies, or inaccuracies, and it aids in the debugging and optimization of AI models. Finally, metadata promotes collaboration and communication within the AI community, as it provides a common language and framework for sharing and comparing and building upon existing AI systems. In this presentation, we will explore various types of metadata relevant to AI, including but not limited to training data metadata, model metadata, and deployment metadata. We will also delve into the history of metadata and AI and its evolution alongside the growth of machine learning and deep learning and its importance in shaping the current AI landscape. As we proceed through this presentation, we will discuss the significance of metadata, standards, and management tools in the AI domain, touching upon some popular examples like ML metadata, MLMD, Model DB, and MLflow. Moreover, we will examine the challenges and future trends in AI metadata management and consider the ethical implications of metadata and AI development and deployment. So, with all of that said, and I know it sounded like a lot, and it is a lot, please join me as we embark on this exciting exploration of metadata in artificial intelligence and its impact on the development, understanding, and responsible use of AI systems. In the context of artificial intelligence, metadata can be broadly categorized into three types: training data metadata, model metadata, and deployment metadata. Each of these categories serves a distinct purpose and plays a critical role in the AI development lifecycle. Training data metadata. This type of metadata provides information about the data used to train AI models. It includes details such as the data source, data quality, pre-processing steps, and data labeling process. Training data metadata is essential for understanding the characteristics of the data, ensuring its quality, and identifying any potential biases or inconsistencies that may impact the AI model's performance. Model metadata. Model metadata sorry about that. So let's talk about model metadata. Model metadata captures information about the AI model itself, including its architecture, parameters, training algorithms, and performance metrics. This metadata is vital for understanding how the model was built, what features it considers, and how well it performs on given tasks. Model metadata also facilitates the replication and validation of AI models, which is crucial for maintaining transparency and trust in AI systems. Deployment of metadata. Deployment metadata relates to the operational aspect of AI systems, such as API endpoints, version, monitoring metrics, and user feedback. This metadata helps AI practitioners manage, monitor, and optimize deployed AI solutions, ensuring their reliability, scalability, and performance in real-world scenarios. Understanding and managing these different types of metadata is critical, or crucial, I should say, for the successful development, deployment, and maintenance of AI systems. To appreciate the importance of metadata and AI, let's go ahead and take a brief look at its history. In the early days of artificial intelligence, AI systems were predominantly rule-based and relied on handcrafted knowledge representations. Metadata in these systems typically involved annotations and descriptions of rules, facts, and relationships with the knowledge base. The purpose of metadata at this stage was primarily to provide human-readable explanations and facilitate the understanding and maintenance of AI systems. As AI evolved and machine learning emerged as a dominant paradigm, the role of metadata expanded. Machine learning models rely on vast amounts of data and training for validation, which necessitates the use of metadata to describe, organize, and understand that specific set of data. The rise of deep learning with its complex models and architecture further underscored the importance of metadata in capturing the intricacies of AI systems. Today, metadata is an integral part of AI development, serving as a cornerstone for model reproducibility, transparency, and collaboration. As AI systems become more and more and increasingly, I'll say, sophisticated and pervasive, the need for effective metadata management will continue to grow. In these next few slides, we will dive deeper, and I mean quite deep, into the various types of AI metadata, discussing their specific purposes and providing examples to illustrate their importance in the AI development process. So let's begin with training data metadata. As mentioned earlier, this type of metadata provides information about the data used to train AI models. It is essential for understanding the characteristics of data, ensuring its quality, and identifying any potential biases and/or inconsistencies that may impact an AI model's performance. Some examples of training data metadata include data source, information about where that data comes from, such as the database, website, or data provider. This information helps establish the credibility and reliability of the data and can inform decisions about the suitability for a specific AI task. There's also data quality. Metadata describing the quality of the data, including the presence of missing values, duplicate records, or inconsistencies. Data quality metadata helps to provide potential issues that may affect the performance of AI models and guide data cleaning and pre-processing efforts. There's also data pre-processing. Information about any pre-processing steps applied to the data, such as normalization, scaling, and transformation. This metadata helps to ensure consistency across different data sets and provides a record of the data processing pipeline, which is essential for reproducibility. There's also data labeling. Metadata related to the process of labeling data for supervised learning tasks, such as the annotators involved, their expertise, the labeling guidelines or instructions. This information can shed light on the quality and reliability of the labels and help identify potential sources of bias or error in the data. Managing and maintaining accurate training data metadata is a crucial aspect of AI development, as it directly influences the quality and performance of AI models. Moving on to model metadata, which captures information about the AI model itself. Model metadata is vital for understanding how the model was built, what features it considers, and how well it performs on a given task. It also facilitates the replication and validation of AI models, which is crucial for maintaining transparency and trust in AI systems. Some examples of model metadata include model architecture, information about the structure and design of the AI model, such as the number of layers, the types of layers, and/or the connections between the layers. This metadata helps to provide an overview of the model's complexity and enables other researchers to replicate or build upon the model itself. There's also model parameters, metadata describing or prescribing the various parameters and/or hyperparameters of the AI model, such as learning rates, regularization factors, or optimization algorithms. This information is critical for understanding the model's behavior and tuning its performance. What about the training algorithms? Training algorithms are information about the algorithms and techniques used to train the AI models, such as the gradient descent and backpropagation or reinforcement learning. This metadata can help researchers identify potential issues, comparing different training methods, and optimize the model's performance. Model metrics. Metadata describing the various metrics used to evaluate the AI model's performance, such as accuracy, precision, recall, or F1 scores. This information provides insights into the model's strengths and weaknesses, and can guide the selection and tuning of AI models' specific tasks. I feel like that was quite a handful, but hang with me. We're a third of the way there, everyone. Collecting and managing model metadata is essential for fostering collaboration, innovation, and trust in the AI community. It enables researchers and practitioners to share, compare, and build upon each other's works, driving the advancement of AI technologies. The third type of metadata we will discuss is deployment metadata, which relates to the operational aspects of AI systems. Deployment metadata helps AI practitioners manage, monitor, and optimize deployed AI solutions, ensuring their reliability, scalability, and performance in real-world scenarios. Some examples of deployment metadata include API endpoints, information about the APIs used to interact with an AI model, such as the URL, request format, and response format. This metadata helps developers integrate the AI model into their applications and facilitate seamless communication between systems. What about versioning? Versioning. Metadata or metadata describing the different versions of an AI model. Information here would include model architecture, parameters, or training data. Versioning metadata enables practitioners to track the evolution of AI models, manage dependencies, and ensure compatibility of different components. There's also monitoring metrics. Information about the metrics used to monitor the performance of the deployed AI model, such as response time, throughput, or error rate. This metadata allows practitioners to identify potential issues, optimize the AI model, and maintain high-quality service levels. There's also user feedback. Metadata related to user interaction with the AI model include user ratings, comments, or suggestions. This information can provide valuable insight into AI model's performance, help identify areas for improvement, and guide future development efforts. Managing deployment metadata effectively is crucial for the successful operation of AI systems in production environments, as it enables AI practitioners to maintain high-quality, reliable, and scalable AI services. In summary, metadata plays a crucial role in the AI development lifecycle, providing valuable information and insights across various stages of the process. The importance of metadata in AI can be attributed to several factors. Model reproducibility. Metadata is essential for ensuring the reproducibility of AI models, which is a cornerstone of scientific research and development. By providing detailed information about the data, models, and processes used in AI systems, metadata enables researchers and practitioners to validate, compare, and build upon each other's works. Debugging and troubleshooting. Metadata serves as a vital tool for identifying and resolving issues in AI systems. It helps developers and researchers understand the components and characteristics of AI models, making it easier to pinpoint problems, optimize performance, and maintain the quality of AI solutions. Bias detection and fairness. Metadata can help identify potential biases and fairness issues in AI systems by providing insights into the data, models, and processes used in their development. By shedding light on potential source of bias, metadata can guide efforts to mitigate these issues and promote the responsible and ethical use of AI technologies. As the field of AI continues to advance and become increasingly complex, the need for effective metadata management becomes increasingly important. In these next few slides, we will explore the various standards, tools, and platforms available for managing metadata in AI, as well as the challenges and future trends in this particular area. As we have seen, metadata plays a critical role in the development, deployment, and maintenance of AI systems. To ensure that metadata is effectively managed and utilized, it is essential to have metadata standards in practice and in place. Metadata standards provide a common language and framework for organizing, describing, and sharing metadata across different AI systems and platforms. Some examples of metadata standards in AI include ML metadata, MLMD. ML metadata is a library developed by Google as part of the TensorFlow Extend, TFX. It provides a standard way to represent and store metadata associated with machine learning workflows, such as data, models, and experiments. MLMD facilitates the tracking, sharing, and understanding of metadata, promoting collaboration and reproducibility in AI research and development. There's also ModelDB. ModelDB is an open source system designed for managing machine learning metadata. It supports the storage and management of information about models, data sets, and experiments, making it easier to track, compare, and share AI models and their associated metadata. What I can say about ModelDB is this. ModelDB aims to improve collaboration and productivity in AI development process by providing a unified metadata management solution. There's also MLflow. MLflow is an open source platform for managing the end-to-end machine learning lifecycle, including experimentation, reproducibility, and deployment. It includes components for tracking and managing metadata, such as data, models, and experiments, which facilitate collaboration, sharing, and understanding across AI projects. The adoption of metadata standards in AI is crucial for promoting transparency, reproducibility, and collaboration in the AI community and community at large as that continues to expand. It enables researchers and practitioners alike to share, compare, and build upon each other's works, diving into that advancement of AI. Now, I would say both diving, but specifically, I would say driving that advancement of AI technologies, which might explain its increasing growth and exponential growth rate. In addition to metadata standards, various tools and platforms have been developed to help manage and utilize metadata effectively in AI projects. These tools and platforms offer a range of functionalities for managing, tracking, and sharing metadata, streamlining the AI development process and facilitating collaboration. Some examples of metadata management tools and platforms include TensorFlow Extend, TFX. TFX is an end-to-end platform for deploying production machine learning pipelines still developed by Google. It includes components for managing metadata, such as ML metadata, which provides a standard way to represent and store metadata associated with machine learning workflows. TFX aims to simplify and streamline the AI development process by offering a unified solution for metadata management, model training, and development. There's also Kubeflow. Kubeflow is an open source platform for developing, orchestrating, and deploying and running scalable and portable machine learning workflows on Kubernetes. It includes components for managing metadata, such as Kubeflow Metadata Component, which provides a flexible, extensible, and scalable way to store, track, and manage metadata associated with machine learning workflows. Kubeflow enables AI practitioners and researchers alike to develop and deploy AI models more effectively and efficiently by providing a comprehensive platform for metadata management and machine learning workflows. There's also DVC, or Data Conversion Control. DVC is an open source version control system for managing machine learning projects. It helps track and manage data. It helps track and manage data models and metadata throughout the AI development process, making it easier to collaborate, share, and reproduce or produce AI models and their associated metadata. DVC promotes a more efficient and productive AI development process by providing a unified solution for version control and metadata management. The use of metadata management tools and platforms is essential for maximizing the value of metadata in AI projects, as it enables AI practitioners and researchers alike to efficiently manage, track, and utilize metadata throughout the AI development process. Now, before we move on, I just want to take a minute to stretch, if you will, with me. Go ahead and take a minute now. As I know what we're covering is a little bit technical, I do want to take a moment to remind you that you can feel free to pause me, stretch, right? So a big thing that I would say as we cover, and I think the best way to say this is, as we cover data that I would say right now might be considered a little bit more technical, but in the future may become a little bit more common knowledge, it's okay to take a break. It's okay to pause. But if you're ready, let's keep going. We're almost there. A few more slides. Just practice integrating, right? You might have to listen to this presentation once or twice. I understand. Let's just talk about the whole metadata thing. You see, I struggle with something just as simple as just saying that. It's okay if you have to watch a slide one or two more times to understand kind of how some of these systems work. But if you're ready to move on, go ahead and let's keep going. Despite the advances in metadata standards, tools, and platforms, there are still several challenges that need to be addressed to fully realize the potential of metadata in AI. Some of these challenges include scalability, include scalability. As AI systems grow in complexity and size, so does the volume of metadata generated and that needs to be managed. This can create challenges in efficiently storing, processing, and querying metadata, especially when dealing with large-scale AI projects or distributed systems. Developing scalable metadata management solutions that can handle the increasing volume and complexity of metadata is critical to the continued advancement of AI technologies. One of the other challenges is also interoperability. With a multitude of AI tools, platforms, and frameworks now readily available, ensuring that metadata can easily be shared and understood across different systems is of critical importance. This requires the development and adoption of common metadata standards and formats, as well as the integration of metadata management and capabilities into existing AI tools and platforms. Promoting interoperability is crucial for fostering collaboration and innovation in the AI community. There's also privacy and security concerns. As metadata often contains sensitive information about the data, models, and processes used in AI systems, ensuring its privacy and security is of utmost importance. This involves implementing robust access controls, encryption, and anonymization techniques, as well as adhering to relevant data protection regulations and guidelines. Safeguarding the privacy and security of metadata is essential for maintaining trust and confidence in AI systems. Addressing these challenges will require ongoing collaboration and innovation within the AI community, stakeholders, politicians, and everyone else, as well as the development of new technologies and approaches to metadata management. As the field of AI continues to evolve, so too will the approaches and technologies used to manage metadata. Some future trends in AI metadata management include automated metadata generation. Advances in AI and machine learning can be leveraged to automate the generation and annotation of metadata, reducing the manual effort required and improving the accuracy and consistency of metadata. Techniques such as natural language processing, computer vision, and knowledge extraction can be employed to automatically extract and annotate metadata from various sources, streamlining the metadata management process. There's also metadata-driven AI development. Metadata can be used to drive the development, optimization, and deployment of AI models by providing insights into the data, models, and processes used in AI systems. This can lead to more efficient AI development workflows where metadata is used to inform decisions about data pre-processing, model selection, and hyperparameter tuning. Metadata-driven AI development has the potential to improve the quality and performance of AI models while also reducing the time and resources required for their development. There's also the decentralized metadata management. As AI systems become more distributed and interconnected, there's an increasing need for decentralized metadata management solutions that can operate across different platforms, organizations, and domains. Blockchain and distributed ledger technologies can be used to create decentralized metadata repositories that provide a secure, transparent, and tamper-proof way to store, manage, and share metadata across different AI systems and stakeholders. Embracing these future trends and innovations in AI metadata management will help to ensure that metadata continues to play a vital role in the development, deployment, and maintenance of AI systems, driving the advancement of AI technologies and its responsible, and I will say this, ethical also, use. The reason I made that statement is because as AI systems continue to impact various aspects of our lives, it is essential to address the ethical considerations associated with their development and use. Metadata plays a critical role in promoting fairness, accountability, and transparency in AI systems by providing insights into the data, models, and processes used in their development. Some ways in which metadata can contribute to AI ethics and transparency include bias detection and mitigation. Metadata can help identify potential biases in AI systems by providing information about the data used for training and model architecture along with the training process. By understanding the source of potential bias, developers and researchers alike can take steps to mitigate these issues, ensuring that AI systems are fair and equitable. Also, explainability. Metadata can contribute to the explainability of AI models by describing their inner workings and decision-making processes. This information can be used to create more transparent and understandable AI systems, allowing stakeholders to better assess the validity and reliability of AI-driven outcomes. There's also provenance and traceability. Metadata can provide a detailed record of data, models, and processes used in AI systems, allowing for better traceability and provenance. This information can be used to assess the quality and trustworthiness of AI models and ensure their responsible use. By incorporating metadata management into the AI development process, developers and researchers alike can better address ethical considerations and promote the responsible use of AI. In conclusion, metadata plays a crucial role in the development, deployment, and maintenance of AI systems. By providing valuable information and insights across various stages of the AI development process, metadata provides reproducibility, collaboration, and innovation in the AI community. However, as the field of AI continues to evolve, there remains ongoing challenges in metadata management, such as scalability, interoperability, and privacy concerns. Addressing these challenges will require even further innovation, collaboration, and the development of new technologies and approaches to metadata management within artificial intelligence. As AI systems become more prevalent and impactful, the role of metadata in promoting ethical considerations and transparency is increasingly important. By leveraging metadata effectively, AI practitioners can ensure the responsible and fair use of AI technologies, ultimately benefiting society as a whole. As we continue to advance AI technology, it is essential to recognize the importance of metadata and invest in the development of robust metadata management solutions that can support the responsible and ethical use of AI. And the reason I say everything, or the reason I have said everything in this presentation, is because as we continue to advance AI technology, it is essential to recognize the importance of metadata and invest in the development of robust metadata management solutions that can support the responsible and ethical use of AI. So, with that being said, thank you for joining me today, and I hope you have enjoyed this presentation on metadata in artificial intelligence, history, uses, and example.